Yo, what's up guys? So today we're going to be talking about functions and how to interpret them. So let's just start off with, what is a function? Well, a function is a relationship between an input and output where every input has exactly one output. And let's go back to our mapping that we were talking about on my last video. So we might have a domain and we have a range. So if we just put down some values, so as you can see here, every input has exactly one output, but each output could have more than one input. So let's say 2 and 4. If we plug in 2 to the function and 4 to the function, we get 2. That can still be a function. And so normally you graph functions with equations. So they might look like y equals x. And this is one of the most basic functions. And so in this case, every input has exactly one output. But if you have a function like y equals x squared, every output could have more than one input. So let me give you an example. If we have y is equal to x squared and we plug in 2 squared, so y is equal to 4, right? But we might have, what if we plug in negative 2 squared and we get 4? So in this case, 2 inputs could have the same output. So one of the largest descriptors of a function is that every input has exactly one output. So if you plug in 2, you can't get both 2 and negative 1. Okay, so as I said before, functions can be represented as those domain and range graphs. They could be represented as equations. They could also be represented as tables. So something where you have your input, which is your x, and your output y, and you have a list of the values. So maybe 1, 2, 3, maybe 2, 4, 6, something like that. Or they could be represented on a coordinate plane as a line, or lines, and I'll get to that in a sec. Or they could be represented as a line on a coordinate plane. So, a coordinate plane, as I've said before, is basically an intersection of two number lines. So if I just draw one here, sorry, it wasn't very straight. So we have our origin, we have the y-axis, and we have the x-axis. Sorry, x-axis. And let's have a really simple equation, or a really simple line equation. So we could do y is equal to x. And if I can get it right, it goes straight through the origin and out the other side. Okay. So it might look something like this. And so this graph is created by plugging in an input at x and getting your output in plotting that spot on the y-axis. So you have your equation, you plug in your value for x, you get your output for y, and you use that as coordinates to be able to plot points on this line. There's two terms I want to talk about right now. One is called a discrete function, and the other is called a continuous function. So let me clear this. A discrete function is when it's not fully connected, or at least there's breaks in the line. A continuous function is when there are no breaks in the line, and it's like a line or smooth curve. So let's get two examples here. So I have two lines right here, and which one do you think is the discrete function, and which one do you think is the continuous function? This one right here is the discrete function. We'll just call it D. And so this is because there is a break in the line. Notice these are not connected. They just seem to jump randomly. While over here, this is the continuous function because everything is connected. Everything is in a smooth curve here. And so this closed dot signifies that that's the actual output for this x value, while this open dot just shows where to start, basically. because you can't have, because if this was a closed dot, this would mean that this y value, or this x value, which is 0, is going to have two outputs, which is not true. Now on the topic of distinguishing functions from non-functions, there's a very easy and simple way you can do this. It is called the vertical line test. And it's literally just drawing a vertical line, and if it on the graph, on wherever you want, and if it intersects 2 points on the same graph, then that means that it is not a function, because that would mean that one x value, one input, has 2 outputs, or more than one output. So let's draw some functions. So we have 3 graphs right here. So let's try to figure out if they are a function or not a function. Well, let's look at this first one over here. So as you can see, it is a curve like this. So let's try. We can just draw a vertical line wherever we want, maybe like this, and like this, and maybe this, or this. So as we can see, it only intersects with one point on the line, wherever we draw a vertical line. You guys may be wondering, well, is there a point where it's going to go straight up and then you can draw a line through multiple points? Well, no, because as you can see, these lines are, this graph is going outward, so it's never gonna go straight up. So we can call this a function. We can say f. Okay. Now let's check this one out here, and right off the bat we can see that this. So let's see if this is a function. Well, right off the bat we can draw a vertical line and see that it indeed intersects 2 points, and we can do this basically anywhere. So this tells us that this is not a function, because every input, every x value, has more than one y value or output. So this is not a function. So let's go over here. So we can draw a line here, draw a line here, maybe draw a line here, and the issue is on this axis right here. And earlier I explained that the solid dot is an actual value, and the empty circle shows that that is an empty value and just the starting point for the next part of the line. So this is actually a function. Of course, if there were to be a solid dot right here, this would be not a function. But as we can see, it was a hollow dot or empty dot, so that means that it is a function. And just one more term I want to get out of the way, function notation. So a function might look like this. So y is equal to, or the equation for a function might be y equals 3x minus 8. How about that? And so this is the equation form of it. But if we were to write it in function form, it would be f of x is equal to 3x minus 8. And so this right here is f of x right now. But if it were to be f of 3, oh shoot, sorry, that was bad, 3. F of 3, it would be 3 times 3 minus 8. And this is helpful in future math levels when you're trying to manipulate and change functions. Now, let's talk about interpreting functions. Well, the first term I want to talk about is linear. So linear means, when it's a linear function, it means that it is a straight line. A nonlinear function might be a curve like this. And what a linear function tells you most of the time is that it's going to be y is equal to x to the power of 1. So there could be other coefficients or constants with it, but normally it's going to be x to the power of 1. What a nonlinear function tells you is it's going to be x to a value that is greater than 1, so x to a value that is greater than 1, or it's going to be a constant to the power of x, which this is right here. Whether the graph is straight or in a curve could tell you a lot about the equation. So now let's talk about the intercepts. The intercept is basically where a line or a graph intersects with the axes. So if we were to draw a graph right here, where would the intercepts be? Well, as we can see, the intercepts are here and here. So this right here is the y-intercept because it's on the y-axis, and this right here is the x-intercept because it's on the x-axis. And now symmetry. So symmetry of a graph can also tell about the exponents. I'm not going to get too far into it right now, but some curves have a symmetry like this. Just pretend it's symmetrical. And you could draw a line right down the middle, and they would be identical on both sides. When I say the same on both sides, the x values are obviously going to be opposite, but I'm really talking about the y values. So see, if we were to go to this certain x, and I don't even know, negative x, and we get this point, if we were to go to the same point, just positive x, it would be the same y value, and that tells us if we can get enough points, we can see that this line, this graph, is symmetrical. And finally, I want to talk about the extrema and end behavior of graphs. Let's first talk about positive or negative. So let's get us a graph right here. So let's talk about positive and negative parts of the graph. So the positive parts are going to be above the x-axis. So this part's positive, and this part's positive. And the spots below the x-axis are going to be negative. So this spot's negative, and this part's negative. So let's talk about decreasing and increasing. It's slightly different than positive or negative. Decreasing is when the line has a negative slope, when it's moving downward. So if we can find all the spots where it's moving downward, like this, those are when the graph is decreasing. And we read it from left to right normally. So to find the parts that are increasing, it would just be whatever part is going up. So it might look something like that. So the blue is increasing, the red is decreasing. So extrema is basically the relative highest or lowest points of a function. So if we were to have 2 points right here, maybe one here, that's called A, and that was bad, A, and one here called B, point B. The point A is going to be called the relative minimum because no other points nearby are lower. Then obviously over here it's lower, but in this area it is the relative relative minimum point. And B would be point B would be the relative maximum because no other points around it in its area are higher than it. So like again, over here, it's higher than it. In its area, it is the relative maximum. And now end behavior. So normally how I said when you're reading it left to right, as in whether it's increasing or decreasing, when you're talking about end behavior, you have to say as x increases or x decreases, y does this. So let me give you an example. As x increases, y decreases, right? Because even though there's some fluctuation here, ultimately, as x increases, y is decreasing. And as x decreases, even though there's some fluctuation here, y is increasing. So as x is decreasing, y is increasing. That would be the end behavior of this function. Hey guys, so thanks for watching. So today we kind of covered functions and how to interpret them. The next few videos we're going to be getting into solving algebraic equations. So I think that's going to be fun. I think it's kind of the basics of algebra. But if you guys think I missed anything or there was something that stood out that you weren't sure about or unclear about, feel free to comment and I would address that. I am using the Glencoe Algebra 1 book to teach out of. I think it's by McGraw-Hill. So yeah, thanks for watching. Subscribe if you like this content, want to see more, and peace.